Welcome to the Science and These Tutors YouTube channel. My name is Tandu Labati, one of the tutors. And before we get into anything else, I just want to say Happy New Year to everybody. And I hope this year is going to be a prosperous and a fruitful one, and you'll be able to accomplish all of your goals. And on behalf of me and my Science and These Tutors family, we would like to extend our deep sense of gratitude to all our subscribers. Now, I know you guys that it's been quite a minute since we've uploaded our first video, and as you guys can remember, we've uploaded our first video close to the festive season, and afterwards everybody just went home to spend time with their family during the festive. And fast forward to January, we were all still at home spending time with our families, and COVID hasn't made things any easier for us as we're unable to get certain material to film our content. However, we have decided to improvise just to show you guys just how committed we are to this channel, and we would like to thank you so much for your patience and for your support. And we're promising you that we are working on some content that is jam-packed with fun, so please stay tuned in. And thank you once again guys for your support and for your patience, and we sincerely apologize for any much delay. Now please stay tuned in again, like I said, and let's get into today's video. Thanks. Okay guys, so today's video is all about acids and bases. Now I'll be showing you guys how to test whether something is an acid or a base using common household items. Now I know some of you may think, oh okay, acids and bases at home, really? Because you guys are probably used to testing, hearing that name in a lab. You're probably thinking about a lab setting when you think about acids and bases. However, you have common household items which have chemical compounds that qualify them as acids or bases. For example, your vinegar and your toothpaste. So let's do a quick recap. Now, I first heard of the term acids and bases when I was in the 9th grade, but I got a deeper understanding of what they were all about when I was in the 10th to the 12th grade. So grade 10s to grade 12, you may be more familiar with the subject. So now, let's define what an acid and a base is. So scientifically, an acid is a proton donor. So acids normally contain what we call H+ ions or hydronium ions, and they contain at least one of those. And a common example of such is hydrochloric acid, which has a formula HCl. And on the other hand, your bases, they are called proton acceptors. So bases contain OH-, also known as hydronium ions. So a common base is sodium hydroxide, NaOH. So guys, another way to define an acid and a base is when you put an acid in an aqueous solution, for example water, it releases the hydronium ions, the H+ ions, right? And a base, on the other hand, it releases the hydroxide ions, the OH-. So bases and acids, they can also react together, and when that reaction occurs, that is known as neutralization. I'll explain what that is in the next video. So when an acid and a base react together, they neutralize each other and they form salt, and the OH- from the base and the H+ from the acid, they combine together to form water. So your products are going to be water and salt, right? So depending on what acid and what base you are reacting, it will determine the kind of salts that will form. So to test for whether something is an acid or a base, we use what is called an indicator. So an indicator that you guys may be commonly familiar with is litmus paper. So an indicator changes color depending on whether something is an acid or is a base. So indicators can be in an aqueous solution, or it can be your normal litmus paper, right? So there are also organic indicators as well, such as your red cabbage and your tea. So in this instance, in this video, we'll be using red cabbage as an indicator. So red cabbage contains a chemical compound called known as flavin or anthocyanin, and what happens is that it changes color in the soil depending on the pH of the soil. So that's why we're using it for this particular experiment, because it's also gonna change color when we either test it in an acid or we either test it in a base. So without further ado, let's get into today's video. I have my glasses on, so if you have your own glasses, there's no need for you to wear safety goggles. But if you don't have your own glasses like me, just wear safety goggles, right? So I have my glasses on, and I have my lab coat here, and I have my gloves. So let's begin. Indicator. As you guys can see, this is the cooled version of it. So here is our cabbage after I've taken it out of the pot, right? So what I did here was I took about 3 cups of boiling water and I added them on the pot, and then I added a handful of cabbage, red cabbage peels, and then I boiled it for about 15 minutes, and then this is the end result, as you can see. So you just have to boil it for 15 minutes and then let it cool, maybe for like 30 minutes or so. So now I'm gonna take my indicator and I'm gonna put it in my jar. Just make sure that you're doing this on your basin so that you don't spill anything. Okay guys, so here I have my dessert bowls, and each dessert bowl contain the different household items that I've chosen to use for this acid-base reaction. And in the first one I have my vinegar, the second one I have my bicarbonate of soda, and the third one is lemon juice, the fourth one is just plain tap water, and the last one is bleach. So now I'm gonna take my indicator, which is in my jug, and I'm gonna pour in each of these dessert bowls. So you guys need to watch for a color change. Can you guys see the difference? So now what we're gonna do, I'll show you guys the pH scale, and what you have to do is to arrange these things according to the strong acids and strong bases, right? And put the neutral one in the middle. So as you can see, all of these things, they've changed color, but they're not in order. So I want you guys to arrange them in the order that they're supposed to be, just to test that you understand. Okay, as you guys can see, I've now arranged this in order, and here are my acids the side, and then you have your water, which is neutral, and you have your bases at the end. So as you can see here, I have my vinegar, which is slightly more acidic than the lemon juice because it has a deep red color. And then I have my lemon juice, which is quite pinkish. And then we have water. Since water is neutral, the color of the indicator is not really going to change, so it remains pretty much the same. And you have our bicarbonate of soda, which is a base, and it changed into a green color. So if you guys have checked the color charts, you'd see that all these colors, they are represented on the chart. And then you have our bleach, which is slightly yellowish, and with bleach, of course, the color is not going to remain a bit green because the bleaching agent inside, it bleaches the color out after you've poured out you've poured the indicator inside. So I hope you guys got this right. So you guys, we're now done with the experiment, and I'm gonna discard these on the drain. Please note that these are common household items, so they're not really gonna do anything. So you can safely pour them on the drain, and then you can wash the bowls and return them into your cupboard. So these are not as harmful as your chemicals that are found in a lab. So if I was using a chemical that is found in a lab, I wouldn't discard this in the drain because it would probably do some reaction.